Okay, units. Now, units are a relative concept. Unlike dimensions, which are absolute or abstract concepts, units are relative. And there are quite a few unit systems out there. Okay, so that makes things a little bit complicated, but it also gives rise to a richer way of operating. There are two systems of units that we mostly deal with. One is the USCS system, which is the US customary system, also known as English system, although English really don't use it anymore. It's also called FPS, for foot-pound second system. In this country, we mostly say USCS system. And the other, the very popular one, is SI, or International System, also known as metric or meter kilogram, MKS system, right? And it has been decided that whole world should really adopt just the SI system. Unfortunately, most of the businesses in this country still use USCS system, so we have no choice but to learn both of them. Okay, you have to be proficient with both USCS system as well as SI system. If there are any international students in this class coming from maybe abroad, let's say Asia, they're probably more familiar with the SI system because that's the predominant unit system used over here. Over here, you have both of them. So you will see problems where you have things given in pound, things given in kilogram. So you have to know how to go from one to another, right? Okay, so we have talked about the base dimensions. These are the generic symbols that we use for them. And we have two unit systems. So in both SI as well as USCS system, each of these base dimensions have what are known as base units. Because they are base dimensions, so we have base units for them. For derived dimensions, you'll have derived units in each system. So in SI system, the length has meter, time has second, which is common, mass is kilogram, force is a derived unit in SI system. So we derive the unit of the force from the base units. For temperature, is the Kelvin, so it's not centigrade, and you have for electric current, you have the ampere. For USCS, the difference is in the length, so this is meter, this is feet, second is common, mass is kilogram, but the unit of mass in USCS system is the derived one. On the other hand, the unit of the force in USCS system is base. So the unit of the force in the USCS system is pound force, sometimes also written as simply as pound, LB. But more correctly speaking, it should be written as LBF or pound force. Temperature has base unit as Rankine, and electric current is same as ampere, right? So in case you're curious, the relationship between Kelvin and Rankine is given by this. So you can see 0 degree is same, right? Because 0 degree R is same as 0 degree Kelvin, okay? But the linear scale is different. So it's not same as centigrade or Fahrenheit.
Isn't the temperature is Fahrenheit in USCS system?
No. It is a derived unit. It is not. Rankine is the base unit in the USCS system. Okay. Although we do use, you're right, we use mostly Fahrenheit in this country. Yeah. Now we don't talk about centigrade that much. Okay. So the thing that you need to pay attention to is this part, the force. The unit of the force in the SI system is derived, but the unit of force in the USCS base system is pound force. So then the question is, well, how do we get the unit of mass in the USCS system? Well, we get the unit of mass in the same way as we get the unit of force in the SI system. It's the same formula, same approach that we take. Okay, so we'll talk about that. Now, how do we get the unit of mass in USCS system? How do we get the unit of force in the SI system? Comes from this formula, which is Newton's second law, right? Newton's second law says that if you are given the mass of an object, if you know the acceleration of this object, then the force applied on the object to cause that acceleration is equal to mass times acceleration, right? That's Newton's second law, F equal to ma. So if you know the force, you know the mass, you can find out what the acceleration would be. In that case, it's more like you know the cause, the push or the pull, and you can find out the acceleration. Or you can say, hey, I know I need to have this much of acceleration because I want to go this fast, right? And I know the mass, so how much force would be needed to get that acceleration? So again, you use the same formula to get that. So if I'm trying to derive the unit of force in SI system, I need to know the units of mass and acceleration, right? So let's substitute that in this formula. So the unit of the dimension of mass is m, and the acceleration is defined as rate of change of velocity, right? Rate of change of velocity. Velocity itself is rate of change of displacement. So the unit becomes, or the dimension becomes, L over t square, right? L over t square. So you can write this as ml times t to the power minus 2, right? So that's the dimension of the force expressed in terms of base dimensions or fundamental dimensions. If I want to get, let's say, the dimension of mass, because I know the dimension of force, which is what we will have in the USCS system, then I just have to rearrange this formula, take t squared on this side, take L on this side, and I will get basically m equal to f times t squared times alpha minus 1. Same formula, we can go from force to mass or mass to force. And we'll use these formulas to get our units in the two systems.